Hi everyone. In this mini lecture, I'm going to be talking about a couple questions, the solutions to a couple of questions that should help you with question 3 on exam 2. So here you're given a code excerpt, um, and you want to determine what number is going to be logged. So the key to solving this type of problem is figuring out when it's going to stop, right? So the until or a while will tell you when the code excerpt is going to stop. So you can see here you're going to stop when item is less than 100. If it were never to reach that point, then you would just keep going forever there, and you would have to probably close out REPL.it or just sit there, right? So you don't want to run this code because this wouldn't run forever, but it would run for a very, very long time. So basically here you have a list of numbers from 0 to 9, 9,999,000,000, 999,999, right? So this is range 0 to 10 million. And since range is going to stop one before the second integer that you give it, it's going to be the number I just said. But it's not going to be on that list because what you're going to do is you're going to reverse that list. So you're going to count down from, as I said before, this big number of 9,999,999,999 down to 0 here, right? But until is going to stop it when item is less than 100. So the way this works, this code excerpt is going to work is you're going to start with an ACC of 0, and you're going to start with that big number here, 10 billion minus 1. And since it's in reverse, you're going to count down. So then it's going to be 10 billion by minus 2, 10 billion minus 3, etc. Right? So ACC is going to start at 0, and item is going to start at 10 billion minus 1. And it's going to check right away. That's the first thing it's going to do. It's going to check, is that 10 billion minus 1 less than 100? And it's clearly not. So you could see the accumulator here. It's going to take an accumulator and an item, and the accumulator is going to go down by 1. So the accumulator here was 0, and now it's going to become negative 1. And the next row you're going to do is negative 1, and it's going to go to the next item in the list, which again is 10 billion minus 2. Right? So then it's going to check, is 10 billion minus 2 less than 100, and it's not. So it's going to go back here again, and now again the ACC is negative 1, so it's going to plug in negative 1 for ACC, and it's going to plug in 10 billion minus 2 now, right, because that's going to be the next item. And it's again just going to take the accumulator and subtract 1, so the new accumulator is minus 2, and it's going to keep going, right? So then you have the accumulator is minus 2, and the item is 10 billion minus 3, and it's going to again check if 10 billion minus 3 is less than 100, etc. So the point is, you don't want to keep going through this and actually tracing this out, because you would be there a while. So we really just want to see what's happening, right? So it's counting down by 1 each time, and it's going to stop when item is less than 100. So, at some point it's going to get down to, let's say, 105, 104, 103, 102, and you still don't have, it's less than 100, so 101, 100 is not less than 100, and then finally 99 is less than 100. Right? So that's going to be when it stops, when item is 99. And since we're getting the item here, you have .item instead of .acc, you don't even have to figure out what's happening with the accumulator. All that really matters is the item, right? So over here, your answer is just 99. Really, so the point for these questions is really just to look at this when you actually are stopping. Again, you do have to know, because this item is less than 100, so you're going to have to know what's happening here. Like for instance here, if we were counting down by 2's instead of by 1's, that wouldn't be range, because range is generating consecutive integers. But if we had a list where we were counting down by 2's instead of 1's, then item would be 98, right? but because we're actually counting at the end. But because we're counting down by ones here, it's just 99, right? Okay, so that should be hopefully simple enough. Okay, and so in this next one here, we again are trying to find what the output is going to be. We have two console.logs that are really going to do the same thing. The code here is the same, except over here we have until, and the body of the function here, the return value of the function, is just that ACC is equal to item plus 8, whereas here we have a while, and the body of the function is not ACC, is equal to item plus 8. Right? So an until really is a while not. And to see this, just think about what this means. So this means that it's going to stop when the accumulator is 8 more than the item. So we're going to stop when this becomes true. Right? So if we stop when this becomes true, we're continuing while it's false. Right? So over here, this is saying we should continue while this whole thing, not of this, is true, right? Which would mean if not of this is true, then that means that ACC equals item plus 8 is false, right? Because not false is true, right? So these, again, say the same thing, and this is completely true in general. So if you ever want to change a condition from an until to a while, just put a not in front of it. So why would we do that, or why would I have you do that? Because in some programming languages, you don't actually have an until. So JavaScript, C++, Python, a number of languages, you don't have the until, you do have the while that you're working with here. So you should be able to write conditions for loops as a while instead of an until. And the point is, though, this is completely straightforward, because as soon as you say, oh, I want to stop when something is true, so you're basically you're figuring out what the condition is for the until. Even if you don't have until in the language, you can just put that in a not, right? So you could surround that condition, put a not in front of it, and then just put it in a while, right? So if you continue until it's true, right, or if you stop when it's true, right, so you continue until it's true, then you are continuing while it's not true, right? So if you stop when it's true, you're continuing while it's not true. Okay, so getting that out of the way there, over here you see that the output 37 is logged twice. So 37 is going to be the final value of item, and here you could see that in both cases, again, because the code is the same, other than just this while versus the until, you're seeing in both cases you're logging the item. So if the final item is 37, that means that you're stopping here, right? The only way you're going to stop is when ACC is equal to item plus 8. So since it's stopped with a final value of item of 37, that means your accumulator has to be 8 more than that, or 45. Right? So again, hopefully this should be pretty straightforward for how to answer these types of questions.